Okay, here's another vector kind of exam style question. So I've got a point and then I've got this line, and it starts off by saying the point P is on the line. And I know what to do. So if P is on the line, then OP is generated by the equation of the line. So OP is going to be generated by that for some suitable value of lambda. So it's going to be 5, 3 minus 2 plus a suitable value of lambda. Oh, and it tells me to take lambda as P. So that value of lambda that generates a particular point P, it wants me to use P for that. Normally you can just leave it as a lambda, but if it tells you to use P, you have to do that. So plus P lots of 2 minus 1, 3. Okay, so that's my OP. All right, so that I just do that because I know that the point P is on the line. So now what do I have to do? I've got to do something with AP, and I've got to dot that with 2, 1, minus 3. And at this point, I don't have to worry about why they're telling me to do this. Later on, I'll have to actually suss out what's going on. But AP, okay, AP is mentioned. How do I get AP? Well, my recipe says that it's OP minus OA. Oh, look, I've just done OP, so I knew that would come in handy. And what's OA? A is this, so the vector OA is just that written as a position vector. So I need to do my OP, which is 5, 3, minus 2, plus P lots of 2, minus 1, minus 3. And I've got to take away OA, which is minus this vector here, 3, 3, 6. And I can shove that all into one column vector. So 5 and a minus 3 is 2, so this is 2 plus 2P. And the next one is 3 minus a 3 is 0, but it's just a minus P then. And the next one, minus 2, take away another 6 is minus 8. So this is minus 8 minus 3P. And then I've got to do AP dotted with the vector 2, minus 1, 3. So that's this vector dotted with 2, minus 1, 3, which I set up here. And so I've got to do this bracket, the 2 times the bracket of 2 minus, so 2 plus 2P. And then 1 times minus P is minus P. And this bottom thing is going to be minus 3 times a bracket of minus 8 minus 3P. So I've just got to multiply this all out. So I get 4 plus 4P minus P plus 24 plus 9P. Okay, so what am I going to get? I've got 4 plus 24, so I'm going to get equals 28. And I'm going to have 4P minus P is 3P plus 9P is plus 12. I don't believe this. What's going on? What's going wrong? What's going wrong? Oh, this was a 2, 1, 3, wasn't it? It wasn't 2 minus 1 minus 3. It's 2 plus 1, 3. So this was a plus P here. So that was a plus P there. So that was a plus P there. So that happens. I mean, you've probably been laughing at me all along for making that error. But when you do find an error, then you do need to check to make sure you find it, and then you need to backtrack and just change it in all the places where it was made. So there we go. 28 plus 14P is the given answer. Okay, that is now right. I'm sure about it. Okay. So, well, yeah, I say that, but I need to put it right here. We need to find when the error was first made. So now I'm right. Now I'm right. Okay, so I've done that. So part B starts with the word hence. So hence find the coordinates of the foot of the perpendicular from the point A to the line L. So look, we need a diagram, don't we? Let's try and make some sense of that. So I've got a point A and I've got a line L. So here's my line L. Here's my point A. Okay, there, line L, point A. And it says find the foot of the perpendicular from A to the line. So we need to draw the point that goes from A and meets the line at a right angle. So that's this. Okay, so that's the foot of the perpendicular. Okay, and this A to this point is perpendicular to the line. Okay, all right. They've asked me to consider this point P, okay, which is on the line. Oh, this point's on the line. And it's asked me to consider AP dotted with something. And we're now doing perpendicularity. And we know that for perpendicularity, I can use the dot product. So AP is going to be perpendicular to this vector. Why did they choose that vector? Because that's the direction vector of the line. So what's going on here is that I've got a line with direction vector 2, 1, minus 3. And this point here that I want to find actually is what they've been making me call P. Because if I make AP be perpendicular to this direction vector, then P will be the point I want, which is the foot of the perpendicular. So in fact, all I have to do for this part is say, okay, I need AP to be perpendicular to the line, and the line is in the direction 2, minus 1, 3. So therefore, AP dotted with that 2, 1, minus 3, test for perpendicularity is that equals 0. But I've just done AP dotted with this vector. It was the 28 plus 14p. So in fact, all I have to do to get my marks here is work out what value of p makes that equal 0. Well, 14p is minus 28, so p is minus 2. And then use that to find the position of p. Well, I've made my life easy because I actually started by writing down what OP was. So OP, if I know what P is, little p, I can sub it into this to find the position vector of P, and that's what I'm going to do. So therefore, my vector OP is, here was the recipe, 5, 3, minus 2 plus, okay, 5, 3, minus 2 plus P, but I now know that this P here is minus 2. So minus 2 times the 2, 1, 3. And when I do that, I get 5 plus minus 4 is 1. And I get 3 minus 2, which is 0. And I get minus 2 minus another 6, which is minus 8. So P is the point 1, 0, minus 8. Good. And then the last part of the question says, determine the shortest distance from A to the line L. So, diagram again. Here's A, here's the line L. Well, I could measure lots of distances, like all of these, but the shortest distance will be when I go at right angles. So, in fact, it's just the length of this vector AP. So, I now know what the point P is. I knew what the point A was. I mean, in fact, I've already done the work for AP, haven't I? I've got the vector AP is this one here. So, one way to do this is to find AP. I now know what P is. P is minus 2. I found it here. So if I sub that into AP, I need to do 2 plus 2 lots of minus 2. So that's 2 minus 4, which is minus 2. And then this P is minus 2. And 8, minus 8, minus 3 times minus 2 is minus 8 plus 6, which is minus 2. So the vector I need is actually AP is minus 2, minus 2, 2. Okay, no, that was a minus 2 as well, wasn't it? Minus 8 plus minus 3p. Okay, so I've got AP is this, so therefore the shortest distance, so AP, I now know the length from A to the line via the shortest route. So the shortest distance is just going to be the magnitude of this vector, which is the square root of 2 squared plus 2 squared plus 2 squared, which is the square root of 12, which is root 4 root 3, which is 2 root 3. And I finished. Hooray.